Hello everyone. I have the pleasure of introducing you Esther Alter, and she is a game developer from Boston, and she's going to talk about procedurally generated monsters. Yes, then.
What's up, nerds? I'm Esther Alter, and this is Procedurally Generated Monsters, a complete example of Python game development. I'm going to talk about a game that I made in Python that I released on Steam and itch.io in 2022. I'm going to explain why I chose to make it in Python of all languages, and how I structured the codebase to utilize Python's advantages over other languages. So, a little bit about me. I'm Esther Alter. My pronouns are she, her. Professionally, I'm a Python Unity C# developer at MIT, but like boring, we're not going to talk about that. I'm not here with them. I'm here to talk about indie game projects. I've been an indie game developer for 13 years, and in that time, I've released 14 games. 3 of those I made in Python. I made Neocolonialism in 2011, Azazel in 2019, and Procemon in 2022. Today, I'm going to talk about that third game and my most recent Python game, Procemon, You Must Catch Them. This is up on Steam and itch.io. So I'm going to tell you what Procemon is and why I chose to make it in Python, and some of the fundamental code organizational decisions that I made. I'm going to show you a cool animation. I promise it's cool. And I'm going to explain how it works. And I'm going to briefly touch on how to upload Procemon, which was an adventure, and conclude with some comments about what I would do differently. So on the first slide, I described this talk as a complete example of game development, but actually I lied. I've omitted some major topics from this talk. I'm not going to talk about how audio works because I didn't want to have to fuss with audio AV stuff, and I don't think chiptune's going to sound good in this room. So I'm skipping that. I'm going to touch on game design decisions, of which there are many, but I'm not going to get too into it unless it is relevant to how I structured the code. We're here for code, so I'm also not going to get into the business, marketing, community management, and so on. All I have to say about that is that if you are an aspiring indie game developer and you want to make some money doing it, the business stuff is about half of what you'll do. So this is a 49% incomplete example of game development. So Procemon, You Must Catch Them is a 2D monster collecting game that runs on a PC. You explore various worlds and acquire cool monsters. Your monsters then fight other monsters in simple turn-based battles. If you've played a JRPG or maybe one particular JRPG, you'll recognize the game mechanics. Procemon is unusual because of how extensively it uses procedural generation. So I don't know how many people here know what procedural generation is, but I'm going to give a brief definition. So procedural generation is where a function generates a random result, but that random result is bounded by an algorithm. So, for example, every map in Procemon is procedurally generated. They're all random, but there are rules and constraints about how much of the map is land versus water, which sections of the map are traversable, and so on. Procedural generation is a well-known technique in game development, and it's been around for decades. The downside of procedural generation is that it's difficult to make anything interesting. Game developer Emily Short famously called this the 10,000 bowls of oatmeal problem. So you can make 10,000 bowls of unique oatmeal, but it's still oatmeal. So the maps on the screen are an example of that. They are all different from each other, but they don't have any unique features that really separate them one from the other. But sameness isn't really a problem in Procemon because the entire game is meant to look lo-fi and glitchy. So there's some kind of fault tolerance to the overall design of it. Whenever something looks samey or kind of weird and off, it actually fits the game better and we can move on. These are some of the monster sprites that Procemon can generate. They look weird, but that's what I want them to look like, so it's fine. What Procemon doesn't include is AI, at least in the modern sense of the word. There are no LLMs, there's no neural networks or like anything like that. As a rule, I think that using AI in games is a mistake. It's resource intensive, and in nearly any case, it's better to pay a programmer to write procedural generation code or to pay a writer to write a script. Thank you. Procedural generation is much simpler and much older than AI. That's all I have to say about that. So, what is actually procedurally generated in Procemon? Well, for starters, each type of monster is procedurally generated. Each save file has unique monsters. The monsters you encounter in the game are totally unique to anyone else's. So you can see that this is a dog monster that has a sprite that kind of looks like a dog, and each dog monster will have a different sprite. There are 72 categories of monsters, such as dog, food, dinosaur. That's a rare example of something that's hard-coded in the game, and they each have a sprite template that's used to generate the sprite. You can also see that these all have a sentence of flavor text. The game's data folder contains thousands of text files that I scraped from Wikipedia, and they're all about topics about the monster types, in this case like beverage. There's a bunch of beverage paragraphs, and then those get put into a Markov chain, and we get this sentence. Each monster also has unique stats. They are procedurally generated. There's constraints on the distribution, so if you have like one really good stat like XP over there, there's like some lower ones. There's also, every monster has a set of battle moves that it can do. The moves are also procedurally generated. The names, the stats, and the status effect, and how probable the status effect is, and the name of the status effect, and so on. Those are all unique to every playthrough, as is the animation for when you actually do the attack. There are 23 algorithms for move animations, and each algorithm has randomized parameters. In Procemon, you teleport to new worlds and explore them. The animation you're seeing right now, well, there is no animation. I messed that up. There is no animation, but this is a unique world, and it's unique every time. Not just the map, but the tiles too are procedurally generated. Like the brown rocks and the beige soil and the trees, all of those are unique to every world and every save file. Every world also has non-player characters or NPCs that you can battle, and each NPC has a procedurally generated sprite. They're all unique. They have their own name, they have their own dialogue when they challenge you. Let's see, what else is procedurally generated? Well, there's the battle entry animation, nearly all of the audio, the splash animation, the badges, so like you get the idea. With a few exceptions, everything in the game that can be randomly generated on the fly is. So, you might think this is really complex code, and in some ways, yeah, but in all the important ways, like, no, it's not, because it's well organized. It took me a total of 9 months from the very first commit to the initial Steam release to make this game. I don't know if you've attempted to make a game, but they're really hard to make. And 9 months is very fast, especially for a game of this scope. As for development costs, I'm going to show you some figures. This is all internal data, so like please don't share it with anyone. I was kidding, you can share it with everyone. I am serious about the $100. I had to pay Valve a fee to put the game on Steam. That was the expense. I made this game alone. So no, I didn't contract out to anyone. I used open source software, and I had a day job. So total cost $100. So how did I do that? And then how did I do it in 9 months? I was able to do it because I opted to make a game in Python. And I made a lot of good code-based decisions early in development. I've made 14 games, and I've learned from a lot of foolish mistakes. And Procemon's code, I think, is some of my cleanest. One of my favorite things about Python coding is that it's really fast and easy to prototype code. This game has lots and lots and lots of branching possibilities, but in Python, it's actually very easy to debug each of them individually. What you're looking at right now is the script containing the core game loop. And you may notice it's really short. Most of the game is in other Python scripts. The key part of the code is the bit that I've outlined. The variable r in red is always a subclass of renderer, which is an abstract class that I wrote. R is initially a splash renderer, meaning that the first thing you'll see in the game is the intro splash screen. Every scene, UI screen, etc. in the entire game is handled in a subclass of renderer. This while loop in orange is the main game loop, and we call r.do, which does something. What that something is depends on how we define the subclass of renderer that r currently is. And whenever renderer.do is called, it returns a new renderer. So you see that r equals r.do. At the start of the game, r is a splash renderer, and it waits until the user presses A, and then it returns a start menu renderer, which in turn will call do, and it will return a new renderer, and so on for the entire game. The reason this game is so easy to prototype is that any renderer in the entire game can be treated as an entry point. Assuming that the underlying game data has been initialized correctly, I can just write a test script for a specific type of renderer and call r.do, and it will start at that point. So like, this is a test script. It tests the army renderer, and the army renderer just shows like who's in your army, which monsters do you already have. This code in red is just boilerplate initialization code. In orange, the script initializes a new army renderer. And in yellow, the script calls r.do, and that's it. That's all I need to make this game immediately jump into the army renderer. I wrote the script in like 3 minutes. I didn't need to play the game to get to the screen. It's extremely easy to set this up. The main game loop of returning renderer after renderer was one of the first development decisions I made, and it made everything else in the game so much easier than it could have been. To debug and troubleshoot. And the reason this works is because I did that in Python, because in Python it's trivial. It's nothing to write a script and just make that the entry point. It's possible to have test entry points in other languages, but like you have to be much more methodical and structured about it, as opposed to this thing which I just like wrote and didn't have to think too hard about it. So before I continue, I do have to mention a caveat, the main caveat to making games in Python. You probably already know it or have suspected it, which is that games, they need to be fast. And sometimes they need to be 3D. And Python, turns out, it's not a fast language. And it can't really render anything in 3D. And to that, I will say, who cares? Procemon is a 2D game, and it doesn't have a lot of simultaneous animation. So like, yes, I had to optimize the code in ways that wouldn't be necessary in other languages, but Python is fast enough for this particular game. If you're new to indie game development, it might be tempting to start with more advanced engines that can handle super complex scenes and photorealistic renderers, or etc., and I encourage you not to do that. Python places a lot of constraints on what you can and can't develop, and constraints are good, actually. Constraints will force you to be creative. I picked a slow language, so I had to be very creative about how to add enough graphical and audio effects to make the game world feel alive. And in Python, and this is a good point, I had a huge toolbox to help me optimize the code. Python has lots and lots of mature libraries, and they all like interconnect really easily. Python might not be the fastest language or even the best language, but it might be the most convenient, and for a project of this size and scope, convenience means that I was able to get something working and stable very quickly. Procemon uses many Python libraries, but the ones doing the most heavy lifting are on this slide. I'm like pygame-ce, numpy, pil, and h5py, and I'm just going to touch on the first two, pygame-ce and numpy. So before I dive into pygame-ce, I just want to say a few quick words because there's been drama since I made this game. Pygame-ce, or Community Edition, is a fork of Pygame. I'm not going to get into what the drama was or what the difference is, but suffice to say, you should use pygame-ce instead of pygame. However, Procemon was made prior to the fork. It does actually use pygame. I'm going to do my best to refer to it as pygame-ce for all of you aspiring indie developers. So pygame-ce is probably my favorite game dev tool in any language. It's a very thin wrapper around SDL that handles rendering, user input, and audio. Pygame-ce is really easy and intuitive to use. It has some of the best documentation in any library out there that I've ever seen, and it's very clear just from like the names of functions and parameters, like what it's actually going to do. Pygame-ce is slow. It's slower than, say, Unity, which I use, or raw SDL. But again, this is 2D. This is a 2D game, and it's slow, and it's fine. We don't need it to be especially fast. For Procemon, pygame-ce has two key advantages. First, it can do pixel-perfect rendering. In a 3D engine such as Unity, this is harder than you would expect. And second, pygame-ce surfaces, and a surface is just like how it handles image data in memory. So a surface can be converted to and from numpy. This is going to be important later. So in Procemon, I used pygame-ce to handle user input, play audio, render sprites. I wrapped all that rendering in a renderer class, and then wrapped every render instruction into a second abstract class called command. Every possible render action in the game is a subclass of command. This command draws a filled rectangle. It's called drawRectangle. In red, the code declares a class called drawRectangle, a subclass of command. In orange, the constructor has fields for position, size, color. In yellow, the script defines this command's do function, which is similar to the renderers. This is where like the command actually does something. And in this case, the command creates a new pygame-ce surface in green, and then it prepares to draw the surface in blue. And this is a possible result. That, if you haven't noticed, is a filled rectangle. Wow. Notice that this command doesn't actually draw this surface to the display. It prepares to draw it by appending it to a list called blit sequence. Blit sequence is a list of pending blit operations, and a blit is just copying pixels from one surface or image onto another. So in pygame-ce, it's faster to blit a lot of things at once. It's faster to just call this once and blit many surfaces rather than to do multiple blit calls. So that is the sort of optimization that you might not need to make in other libraries or systems or engines that has to be done in Python to make this game performant. And it's an interesting constraint because having to blit a lot of things all at the same time puts constraints on which animations are easy to do and which are hard. I don't really consider Procemon to be a pygame-ce game because first off, pygame-ce is not a game engine, it's a library, and second off, most of the logic in this game that actually does the procedural generation is handled by numpy. Numpy is great for game development because it's fast. Procemon opts for numpy rather than pure Python whenever possible. I used numpy to manipulate image data as 3D numpy data, where the axes are width, height, and then RGB. Numpy, doesn't run on a GPU, so it's not actually a graphics shader, but I used it in many cases to do shader-ish things. And the best part of NumPy, as far as Procemon goes, which means as far as I care, is that you can convert it from a pygame-ce surface to you can convert a pygame-ce surface to a NumPy array and back at like practically no cost. So Procemon handles most of its image logic in NumPy, and then as a final step hands the images over to pygame-ce for render. This is a procedurally generated animation. It makes a little squiggle on the screen, and it is created using NumPy. And this is a truncated version of the code used to create it. So in red, the script gets a bunch of random numbers from NumPy. In orange, the script gets a copy of the game's display surface and converts that to a NumPy array. In yellow, the script starts a loop to set up each animation frame. So we're going to we're going to set the values of a NumPy array for every single frame. And in green, assign function is applied to the positions of each pixel, and then this calls numpy.roll to actually roll the pixels from one position to another. And that's how you get a squiggly sign animation. So, as promised, I'm going to show you a cool animation. That wasn't the cool one. This is the cool one. This triggers whenever you enter a new world from the hub world or vice versa. I want to just take like 10 seconds, see if you can guess how this works. I've slowed it down so you can like take a look. All right, high level explanation of what's going on. The top image is a noise array, which is just random values with some kind of algorithmic structure to it. The noise array has values from black to white. And then if you picture that as an elevation map, you got one world going down the map and one world going up the map. And that's what it looks like if you were to like visualize it. This is the code used to generate the algorithm. This might look like a lot of code, but it's not. It's just a PowerPoint, so it looks like a lot. In red, the script gets a copy of the surface of the world that we're entering and a copy of the display surface, which happens to always be the hub world. In orange, a noise array is defined, so values, float values from 0 to 1. In yellow, the script starts a loop to set each animation frame. In green, the script creates a randomized glitch array. This is completely random pixels, but pulled from a palette of 5 different colors to get this just like random noise effect. A few of you might recognize this is from a particular game from 1998 on a Game Boy. The real meat of the script is the part that's outlined in blue. So each frame in the numpy array and each of its pixels is set to the glitch array, the world array, or the display array, depending on a comparison between the noise array's values and the mask's values. Where the mask value is the thing that we are iterating on. So in sort of magenta, the mask value is incremented, and that's how we go through the loop. So that as it's incrementing, that means that there are first way more world pixels than hub pixels, and then those two percentages flip over successive frames with a roughly consistent number of glitch pixels in between. And that's how you get this effect. It looks like a shader, and it looks like it's doing some kind of cool crossfading trick, but it's not. This is entirely CPU bound. It's generated on the fly, and it uses like really basic numpy logic to broadcast numerical data from one array to another. So I want to touch briefly on deployment because, in my opinion, this is Python's great weakness when it comes to game development, and the one that matters. Unlike speed, who cares? I used py-installer to freeze the source code into an executable. There are huge drawbacks to doing this. First, py-installer won't actually protect your source code. What it does is unpack the project into a temp directory. If you care about this, and to be honest, I don't, you would need to use a different tool. Second, py-installer can't cross-compile between OSs. This is like pretty typical for tools, but like coming from Unity, this was a hurdle to figure out. In the past 2 Python games that I've made, I compiled Windows, Mac OS, and Linux. Just like, it was terrible. I had 3 machines and I did it manually. Do not do this. For Procemon, I used GitHub workflows, and each workflow runs a OS, and then it compiles and uploads. So it has to upload to itch.io as well as Steam. Now, itch.io, this was trivial. What the runner does is that it downloads and installs Butler, which is just a command line executable provided by itch, and then it runs Butler to upload to itch. That's all. Steam, it's a different story. Steam has a command line program for updating content, or uploading content, but there's a step in the installation process where you have to manually press something. There isn't a like -y flag where you can like forego user input. You have to press it. So you can't use it in a CI/CD context. So this is what I did. I compressed and archived the game in the GitHub workflow, and then the GitHub workflow FTPs that archived onto my personal website. Every minute, a Python script running on my local machine checks if all 3 archives, Windows, Mac, and Linux, are up on my website, and if so, it downloads the archives back to my local computer, which has the Steam command line tool installed. Then the Python script then executes that tool and uploads the games to Steam, and then I have to manually publish the release. This sucks. It's horrendous, but it's indie game programming, so somewhere along the line, you have to do something like this. It's the rule. I'm going to end this talk with a few words about what I would do differently. I released Procemon 2 years ago, so I've had time to have some hindsight about it, and to be honest, I'm really proud of this code. And a lot of the game design and gameplay decisions that I made. I would really change only some very minor pieces of it, such as that whole installation process. I might give a second pass to, or upload process. Python really was the best decision for this project, and the process of making this game felt pretty smooth and easy. I'm satisfied. The only big change I would make is the actual business and marketing plan, but that's out of scope, so who cares? I really do believe that Python can, in certain situations, be not just a good game dev tool, but the best one available, and I encourage you to try it. There is a lot you cannot do with Python to make a game, but there is a lot you can do, and that means you'll be working with interesting constraints. Try to have fun with them. We have 3.5 minutes for questions.
Hey. Yeah, thank you for talk. I was wondering, have you tried a hybrid approach? So for instance, we're using a C++ and graphic engines, and we have shaders, we have everything, and we're using Python for handle the game logic. So could it be combined? Have you tried something like that?
I haven't tried it. It could be done that way, but at that point, if I'm already using fast compiled code, I would probably just make the entire game in it and be done with it. I wouldn't see the reason. If I'm going to take that path, I'm not going to make myself do extra work.
Thank you. You mentioned that you use a procedurally generated code for a dialogue. Do you use any tools for that, or is it just coded for the game?
It's purely a Markov chain, and the text was scraped from Wikipedia, and that was done beforehand. It's not done on the fly, so I didn't get into that. But it would take a while to explain how exactly I did that, but it was mostly automated. And the fact that it is all Wikipedia text means that it's a uniform, erudite voice. So everything sounds very informative, but doesn't make any sense. So it all kind of works.
Thank you.
Thanks very much. Great talk. I wish I had seen it a week ago before I gave the procedurally generated lecture in my own game class. It would have been really helpful. I'm curious, with so many things that are procedurally generated, how do you go ahead and make sure that the game is still a fun, engaging game where we're not just in essence, rolling a die to see whether we won or not?
I think a lot of the game's fun is meeting these freakazoid monsters. That is the fun, is just exploring this bounded chaos and finding weird stuff. There are enough bounds on each of the systems that things can't get too out of hand. So there are bounds on the stats, so the game is vaguely balanced.
Thanks very much.
Thanks so much. I wonder from there's lots of people that like to use these reinforcement learning agents to play games, and that kind of one of the things they study is can you generalize to slightly different settings? I wonder, this seems like from a research perspective, very interesting environment for that? Is that something like people have approached you about, or something you've thought about?
Well, that's what I do professionally. So there's a reason looks a little similar. So the answer is I would never do that because this is the fun project.
I was curious how you got the guts to start, because some of the stuff like this, it just feels so overwhelming when you look at it that it's really hard to even just write the first line. So how do you write the first line?
How do you write the first line? So this is my 13th game or 14th game, so that helps. It gets easier to picture the first line. But the first line I usually do is the hard part. Whatever I think the hard part's going to be, I attack that first. And if it's like, oh, it's actually really hard, then I don't make the game.
Okay. Thank you.
In this game, the first thing I did was sprite generation and flavor text. I was like, that has to land, and if that doesn't like actually like gel together, then like there's no point in making this. And it did gel together, so I was like, okay, there's a point to making this.
Thank you.
Great talk. Since you've done Python games over look like 10 years, what would you say has changed the most, hopefully for the better, with doing games in Python?
So much has changed. I mean, like the most important thing is that like I had no idea what I was doing the first time around. that was my first game, and it's very poorly made. The two big changes is that like I started the first game I made was Python 2.7 and a very old version of Pygame. So like the jump to was it 1.9 in Pygame, and like Python 3 is huge in terms of like what they can express and how fast they are.
Thank you.
So you said the audio was out of scope, but how did you manage the audio tracks for the game?
They're procedurally generated. There is an algorithm that it has a pool of notes. It knows what notes are, knows what frequencies are, and then there are like 4 or 5 music tracks that are not music tracks. They are just scripts to put them together. So like it can pick chord progressions. It can decide what the next chord progression is. It can decide like what the rhythm is, and it will then just like make it all fit together. It also generates UI sounds on the fly. So like every time you hit A or start, it's different for every world.
And then you mentioned investing $100 to get it rolling. How much have you gotten back from, well, after submitting
Well,
it?
those are actual internal figures, so I won't say that. I didn't spend much time marketing this, so like not much. You know, it's very, very hard to like actually make money doing this, and this was a hobby project. Cool. Okay.